your first unit exam went well in chapters 1 and 2. If it didn't, then do some review, get in touch with me, and I'll see how I can help you out. And I also hope you've been able to make some progress in our introduction to lines and graphing. So I'm just going to do a quick overview on the big ideas from this week. That'll also lead us into linear equations next week. So the big ideas are lines, equations of lines, and the slope of a line. So here I have an equation, y equals 2/3 x plus 1. And it's my belief that this line in red here represents all possible solutions to that equation. So an equation has solutions if when you plug in numbers for the variable or variables, it ends up being true. For example, if I plug in 1 for x here, then I'm going to get 2/3 times 1 plus 1. Well, that's just going to be 2/3 plus 1. I could say 1 is 3/3, so then I get y is 5/3. 3 goes into 5 once with 2 left over, so that's 1 2/3. So let's see. If I went over 1 for x, and then I went up 1, and this would be 2 up here, because that's 5. So I could label that 2, 3, and 4. That's 1.5 right there. So yeah, that's about 1 2/3. So that's the point I just found. Now, what I mean by true is here my claim is y is 5/3. So if I plug that in for y, I get 5/3 is equal to 2/3. I believe x is 1, 1 plus 1. And up above, I already showed the arithmetic for this expression right here is the exact same thing as 5/3, so this is true. That's that point on the line right there. And what a graph of a line is, it represents all possible solutions for this right here. So for example, if I zoom in right there, that looks like the point 4.5, comma 4. So I believe this point is on the line, which means it should make that equation true. Now, I'm not going to do all the arithmetic for that. I'm just going to plug it into a calculator. My favorite graphing calculator is something called Desmos, which I mentioned in the beginning of the course. It's listed on the syllabus. So I'm just going to type in my equation on the right side, which is 2/3. Here I'm plugging in 4.5. I'm going to put that in parentheses, and then I want to add 1 to it. And Desmos says, yep, the answer is 4. Okay? So that means, like I show in my picture, the point x equals 4.5, y equals 4 is a solution to that equation. If somebody else said, hey, I think the point, let's see, let's pick a different point. Let's say 10.7 is a solution, question mark, I don't know. Well, I could plug in 10 for x here and see if I get a matching 7 on the other side to check. So I can whip out my calculator and I can do a calculation. What is 2/3 of 10, close parentheses, then add 1. And the computer says it's 7.666, which is 7 2/3, but not 7. So what that tells me is back here, this is not a solution to this equation up here. And all you have to do is plug in x and y and see if it makes it true. So just to double check, my equation says y equals 2/3 x plus 1. I'm testing to see if the point xy, which was 10.7, is a solution. So I plug in 7 for y. I'm hoping it's equal to whatever 2/3 times 10 plus 1 is. And my computer, my calculator said that was 7 2/3. Is 7 equal to 7 2/3? Answer is no, right? This is false. So since that's false, that point right there is not a solution. All right. So how do we find the right solutions? That's actually not that bad. So what I'm going to do is just, so I think I'm going to erase some of this stuff. Let's get rid of that, and that, and that. All right. So given an equation, how do you come up with the line? So a couple different ways. One way is just to pick some numbers to plug in and see what happens. So 0 is usually a pretty nice number to plug in for x. So if I plug in 0 here, I have to figure out what is 2/3 of 0 plus 1. Well, 2/3 of 0 is 0, plus 1 is 1. So on the graph, I should have the point x equals 0, y equals 1, x equals 0, y equals 1. Check, got it. Now, since 3 is the denominator here, it'd be nice to get rid of it. So the trick is pick x values that are related to 3, like 3. Because if you take 2/3 of 3, the 3's cancel, you get 2. If you add 1 to that, you get 3. So I should have the point 3, 3 on this graph. So let's see, that was 5 right there. 1, 2, 3, 3. Yep, check. That point's on there. That point's on there. Another multiple of 3 I could plug in would be -3. What's 2/3 of -3? Well, the 3's cancel, but it's negative, so that's -2 plus 1, which is -1. So according to this, I should have to point -3, -1. So if I go over left, 1, 2, 3, and down 1, there's my point. Check. Let's do one more. If we plug in 6, then y would be 2/3 of 6. That would be 4. You add 1 to that, you get 5. So I should have the point 6, 5. So that's 5. This would be 6 if I go up 1, 2, 3, 4, 5. Nailed it. There's a point on my line. Check. So usually what I do is if somebody gives me an equation and I'm asked to make the line, I do at least 3 points and I pray that they line up. Now, some people might say, hey, 2 points make a line. But what if you made a mistake? You won't know it. So plot at least 2 points. Now, in a computer system, it's a little bit trickier. So if I go into the 3-2 homework, where I'm doing graphs of linear equations, some of them give you an equation and they ask you to graph it. So this is a case where I'm going to have to make a table and use that table to plot the points. So I'm going to bring this into my notebook and a new screen. And let me just copy. I need to sketch that graph right there. So I'm just going to make a table for x and y like before. I'm going to pick easy numbers like 0. 3/2 times 0 minus 2 is 0 minus 2, which is -2. So there's 1 point on the graph, 0, -2. Now, since 2 is in the denominator, picking multiples of 2 is the smart choice for x. So 3/2 times 2 minus 2. 3/2 of 2, the 2's cancel, gives me 3 minus 2, which is 1. Now I'm going to get one more point to make sure they line up. So let's plug in, I would either pick 4 or -2. Let's do -2, just for fun. So 3/2 times -2. The 2's cancel, but it's a positive times a negative. So I get -3 minus 2 is -5. All right, so those are the points I think that I have. So I just want to see if they line up. So now I'm going to go back to that grapher and just kind of mess around for a moment. So I have 0, -2. So I'm going to use the points. 0, -2. I also had, what was it, 1, 2, excuse me, 2, 1, there we go, 2, 1, and then I had -2, -5, which is way down there. And look, those do line up right there. Okay, now the way to graph on here is not the way I'm doing it here. I'm just kind of checking things out. So I'm going to clear that. I want to use the line tool, and I just pick 2 points. So if I pick, let's see, 0, -2, and then 2, 1, Those 2 points make my line. And I can see down here, they do pass through the point -1, -5. And then I can check my answer. I could get video help, submit it. Oh, I made a mistake. Shoot, what did I do wrong? Oh, it was 1, 2. I plugged in 1, 1. Darn it. Clear, try it again. Or was it actually, no, I better look back on my notes. What did I say? It was 2, 1. Ah, darn, wrong one. Okay, try that again. Oops. 0, -2, and 2, 1. There we go. Oh, and the other point was -2, -5. Okay, there we go. Now I'm on track. Helps if I could see my notes. Ah, now I got a green. Got it right. All right. Other big idea is the idea of slope. Let's go back to this picture here. Slope is the idea of rise over run. Rise is your change in the y values. And run is your change in the x values. Okay, so change in y is the numerator, that's vertical change. Change in x, horizontal change, is the denominator. That's how you do slope. So it tells us how to get from one point to another. So for example, if I want to get from, let's get the highlighter, this point right here to that point right there, let's use blue, I need to go up 2, and I need to go right 3. So this tells me the slope is 2 over 3. Okay, so let's suppose instead, let's pick a different scene. I want to get from this point over there to that point over there. So to make that happen, I'm going to have to go down 1, 2, 3, 4, 5, 6. And I'm going to have to run 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going left, so that's a -9. So I can also say my slope, and these better be equal, is -6 over -9. Now let's reduce that. Negative over negative is a positive. 3 goes into 6 twice, 3 goes into 9 3 times. So hey, I get the same slope no matter which 2 points I pick. These triangles, this one here and this one here, have the same shape. That's another way to think about slope. All right, that's it for now. More in the future. Take care, do good math. See you later.